Okay, so it was brought to my attention the homework I assigned yesterday, I put due Wednesday when we come back from break. So I'll give you guys until Wednesday to do that. Then I guess on Wednesday we'll be wrapping up the real world problems, real world word problems. And we'll be moving on to some other trigonometry stuff. We're still with trigonometry for a little bit. Fortunately or unfortunately, depending on how you feel about the subject. So today we're going to do a short mini lesson. It's something that I don't think it's going to be on the final. They definitely don't talk about it much in AP Calculus. But I think it's pretty cool to know how this works and just to kind of get a general understanding, just in case, who knows. So today we're going to be talking about something called bearings. Now, when I was in pre-calculus way back in the day, when I was, a junior like you guys, we talked about this topic, and I actually just emailed my old pre-calc teacher because every time I teach this topic, I'm reminded that we started learning bearings, and there's this one girl who was in the class who, let's just say, I don't know how she made it to pre-calculus, but we brought up the topic of bearings, and she goes, "What is that? Is that what bears do?" And no, it is not what bears do. Bearings is a way to figure out navigation, and it's used mainly by, well, two people, pilots, air travel, and captains, water travel. So some of these phrases and words might sound familiar, but now we're going to tie it into our trigonometry. So
Man, you came for that girl's neck, Mr. Murray.
it makes me laugh every time. Every time I see the word bearings, I just think, oh, it's what bears do.
I didn't want to say anything, but I was over here dying.
Okay, so we use this in navigation and also in surveying land. I might have said, you might see the construction crews before they begin actual construction. You see a guy out in the middle of the street, and he's got that tripod, and it looks like he's got a camera on there. But actually what that does is it measures north, south, east, and west, and it measures the degrees so that, on the blueprints and then in all their technical work, they have the directions and everything like that. Sometimes they have to figure out which direction the pipes are going in order to hook up a pipe to a building. Or if you're building a house, right, you want to know which way is facing north, south, east, west. So you build the house in the right way so, the maximum sunlight gets through, a whole bunch of stuff like that. So let's get to the definition. All right. So how we use bearings? We have a fixed north and south line. Now, obviously, it's always going to be fixed because north is always north, south is always south. So we use that, and the acute angle the path that we're going to, right? So I set up my my surveying tool, and what that does is it automatically knows where north and south is. So wherever you move the camera, the little lens part, it gives you an angle in reference to north and south, right? So obviously we have our other directions, west and east. Right, so maybe I'm looking up north and I'm not looking directly north, but I'm looking maybe over this way, right? So I would always make my angle. Now this is different than what we've been doing and angle of depression and elevation. With bearings, we always set up the angle with the vertical line. All right, so I'm not worried about this angle here. I'm looking at this angle here. Okay, so whatever this is, say that this is 35 degrees maybe. So what I would say here is that this direction, if I wanted to travel in this direction or if I wanted to build something in this direction, I would say that I would have to go north 35 degrees east. That means I'm looking in the north direction and then I turn 35 degrees towards the east. Okay. The way we say that, though, or the way we say, in layman's terms or whatever, we would say 35 degrees east of north. Right? If I told you that, if we're in a boat or something and we have to go back to shore and I'm looking at the shore and, we have the compass. And I say, oh, well, to get back home, we have to travel 80 degrees west of south, all right, we would write that south 80 degrees west. So that tells me I'm starting off in the south direction. From the south direction, I would move 80 degrees, which is almost all the way west, towards the west way. So this here would be south 80 degrees west, like that. Right, so with this, depending on how we're looking at it, we could find out how far we have to travel in each direction. We can use trigonometry to find, the total vertical distance, the total horizontal distance, longitudinal and latitudinal direction. On the map, you have the grids of longitude and latitude. So you could set it up that way. So there's an example here, but it's a little much. Let me see if I can get a better one. Let's take a look with some numbers. All right. So here we have an example. So a ship leaves a port around noon and has a bearing of 29 degrees south of west. The ship sails at 20 knots. Now, knots is just a term for speed on the water. It is nautical miles per hour. A nautical mile is close to a mile, but it's a little different. Why they use a different nautical mile, that I can't tell you. I'd have to do some research on that. So I want to know the displacement. How many miles south did the ship travel, and how many miles west did the ship travel by 6 p.m.? So we got a few things going on here. We not only have to find the distance it traveled, but then we have, then we have to use a little physics, right? And we know that the speed, the velocity, is distance divided by time. So I want to know, how many miles did it travel? Well, if we're given the speed, well, then I want to find the distance, which is going to be the velocity times the time. Right? So we can find all of that out. So first we're going to set up our cardinal directions. All right, that's what it's called when we have north, south, east, and west. Okay, those are known as our cardinal directions. All right, I drew it like this just because we're only dealing with southwest, so I don't really care about the top. All right, so I would draw my 29 degrees from the south. So it would go 29 degrees this way towards the west. All right, so I could put 29 degrees there. So the first thing we want to know is, how long is this line going to be? Well, if I traveled for 6 hours, right, from noon to 6 p.m. at 20 knots, well, that means I'm going to travel 120 nautical miles. Right? So this line here is going to be 120 nautical miles. Now they are asking us to find how far south did it go, and how far west did it go. Now here I set up a triangle that doesn't really fit, so I'm going to move that. Right? So what's nice about this is we can set up triangles in a few different places. So even though I made the line this way, I can travel south this way and then west this way. Right? And there's my right angle, and now I have a right triangle. Right? If I just focus on that right triangle, that's what it would look like. So I'm going to label this S for south because I'm traveling south, and I'm going to label this W for west, but you can label it anything you want, X, Y. So now that we have this triangle set up, we know one of the sides, we know one of the angles, we can use trigonometry to solve. Now luckily here, it's just straight trigonometry. We don't have to worry about doing any inverse things, right? So for the south, well, first of all, the 120 is my hypotenuse. So my hypotenuse is involved with both of these, so I'm going to be using sine and cosine. For south, I have the hypotenuse and the adjacent, so that's going to be cosine. Right? And for west, that would be the opposite and the hypotenuse, so that would be sine. Right? So remember, to solve these, we just have to multiply by 120. So I could do cosine of 29 times 120. Be careful. Last time we dealt with angles, we were dealing with radians, so make sure we switch to degrees. So I'm going to have 120 times the cosine of 29. Oops, wrong button. So we traveled 100 and we'll say 105 miles south, nautical miles. Right, and then for west, we would do the sine. So I would do 120 sine of 29, and that is 58.2, we'll say. Right, and then from this, we can even go further, and we can give our directions in x and y axis. All right. Now that's something that we can tie trigonometry to into physics and stuff like that. For those of you in physics, when we're talking about things like projectile motion, right? So if you have, maybe a cannon and you shoot off a cannonball, right, and it travels in this parabolic motion, right? Anytime we have projectile motion, it's a parabola. Well, we have the gravity factor, the positive, the vertical factor, right? So the velocity in the y direction, and it's made up of the velocity in the x direction, right? And that resulting two velocities gets us some diagonal trajectory, right? So it's all kind of tied into this trigonometry stuff. All right, any questions about that?
No questions.
Mm.